What is an antenna? See, let me tell you what is the science behind antenna. Because you need to understand the electrical and electronics here. Whenever in a wire there is a fluctuating current, there is an alternating current. In different direction it is moving. So electrons are moving. Whenever electrons are moving, they are going to create the electric field. Whenever there is an electric field, there will be a magnetic field. So whenever we have this kind of alternating current, the electrons are moving. And a current with the time harmonic variation, that is the alternating current. Here, the electron gets accelerated and deaccelerated. So it changes the electric field and the magnetic field. And that how whenever the electric and magnetic field will change, there will be a production of electromagnetic waves. There will be a creation of waves which are called the electromagnetic waves because of the electromagnetic field. Okay. Now when the electrons are moving fast, the waves are faster. They will be created faster. They will be running faster. So the radio waves, see, whenever you have this radio waves, this is the input and simply wires are there. Bend the wire. This will come out. It will go to the free space, right? Now the free space, it can go anywhere. It has it has a pattern. Every antenna has a pattern. It has a diversity. It has a direction. It has a gain, etc. I'm talking about a general sense that these electromagnetic waves are coming out. So when they come out, they come out with the speed of light, 3 into 10 to the power 8 meter per second. Now the speed is quite higher. Now there is a same type of antenna on the other side doing the reverse work. That is, the electromagnetic waves are coming. When it is coming, if the receiver can receive it, and these electromagnetic waves can produce the electron to move. The electron moving can create the voltage or the current, whichever you want. So this is how the reverse process works. So transmitting antenna, here the electromagnetic field is generated so that the waves goes on, and on the other side things are on the reverse track. So radio waves travel through the air at the speed of light. Antenna is also called as aerial. When the waves arrive at the receiver station, they make electrons vibrate inside it. So the antenna, also called the aerial, I am giving you the definition now. An antenna, also called aerial, is an electrical device that converts the electrical power into electromagnetic waves. You can also call it as simply radio waves and vice versa. This is very important because antenna is both. It is a transmitter, it is a receiver also. So again, an antenna is a metallic structure that captures and transmits radio electromagnetic waves, or simply you can call it as radio waves, or you can also call it as electromagnetic. So antenna is an electric device. It is a metallic structure, captures and transmits the radio waves, converts electric power into electromagnetic waves. There are different types of antenna, 3 broad categories. Let us discuss. This is the omnidirectional antenna. This is the directional antenna. And we have a semi-directional antenna. For example, this one. It is directing in two sides. So when it is all direction, omnidirectional, directional means single direction. And when you have 2 or 3, we call it as the semi-directional. So let me show it here. This is the isotropic antenna. This is say propagating, or the electric energy it is spreading everywhere. The gain will be 0. This is the isotropic antenna, and this is physically not possible. This is not possible. And then we try, the antenna makers, they try to make an antenna to only point to one direction. Why? Because the receiver is also is in one direction. It is not everywhere. So you get a gain, and that gain is some number. For example, 5 dB is the gain. So we have 3 types: omnidirectional, directional, and semi-directional. Let me tell you a few things about electromagnetic waves, because in order to understand the parameters of antenna, this is the wave structure. This is how it goes. Now this wave, the tops are called the crest, the below are called the troughs. So troughs and crest The distance between the crest and trough, this is called the wavelength. Lambda, represented by lambda. Now the central line by which this wave is oscillating, the distance from the central line is called the amplitude, and the frequency is number of oscillations per second, and the reverse of, that is the reciprocal of frequency, is period. Frequency is in hertz. Wavelength and others are in meters, centimeter, whichever you want.